Hi and welcome back to my channel. This week's problem is about finding the radius of this circle. As you can see, we've got this chord AB and that has been split into lengths 3 and 4 made by this blue line CD or DC that goes from the circumference of the circle to the point D on that chord. Now that line segment CD makes an angle with BD of 60 degrees, and you can see the corresponding lengths there on the diagram. Can you find the radius of this circle? Now if you want to solve this problem yourself, pause the video now. Otherwise I'm going to show you my solution in 3, 2, 1. Okay, so the first thing is that this is not drawn to scale, so let's be aware of that. I know it says it in the corner, but just to make everybody aware, because that will come up again later on. So the first thing that I want to do here is, I know I've got that 60-degree angle. I want to make a right angle there, so I'm going to introduce this line which meets that blue line at 90 degrees. Now what that allows me to do is start working out the different sides of that right angle triangle. Now I'm going to work out this side here. Okay, so that's opposite the 60, and I'm going to use right angle trigonometry. I'm going to do sine 60 times 4 is equal to 2 root 3. So let's put that on the diagram there. Now you can then use right angle trig again, or you could use Pythagoras for the other side of that right angle triangle. Now I'm going to use Pythagoras, so hypotenuse squared take away the other side squared gives you the final side of that triangle, which is 2. So let's put that on the diagram. I'm going to split that 12 into 2 and 10 for that blue line segment. Now the next thing I'm going to do is I'm going to actually extend that blue line all the way to the circumference of the circle. Now I'm then going to use something called intersecting chord theorem. Now what that means is that I can work out this extra bit, the bit that I've just extended that blue line, and I can do that by doing 3 times 4, so one chord from basically the circumference, the distance from the circumference to the point of intersection, times by the circumference to the point of intersection is equal to circumference to the point of intersection times by circumference to the point of intersection. So what that means numerically is 3 times 4 equals 12 times by this length we're trying to work out, that question mark. Now when we work that through, we get 12 equals 12 times something, and that something therefore has to be 1. So we know that this length here is 1. Now we're going to do a very similar thing, and we're going to use that one we've just worked out to work out this length here. Okay, this question mark. So this remainder of that black chord. Okay. Now we're going to use exactly the same principle here, intersecting chord theorem, except this time it's with the blue line or blue chord and with the black chord. Okay, so what we're going to do is we're going to do 3 times 10 is equal to 2 root 3 times by that question mark. So you've got circumference to the point of intersection times by circumference to the point of intersection is equal to circumference to the point of intersection times by circumference to the point of intersection. Right, now that gives us 30 is equal to 2 root 3 times by that missing length. Divide both sides by 2 root 3 and we get 5 root 3 is equal to that missing length. So let's put that on the diagram. Okay, now from there, this is probably the nicest bit of this solution, I think. So what I'm going to do is I'm going to take this blue line, and I know because of the symmetry of the circle that there must be another blue line of exactly the same length that is parallel to it in the circle as well. So I can do this. Okay, now I know that because of the symmetry of the circle. If I was to use the line of symmetry that is perfectly parallel to that blue line, I'd get this second blue line. Okay, now what I'm doing here is I'm actually creating, in a second you're going to see, a rectangle. But before I do that, I'm going to split up this 5 root 3. Now again, because of symmetry, I know that the line segment to the left of this blue line, so this bit here, has to be 2 root 3, which then means this middle bit has to be 3 root 3. And that's why I said at the start this is not drawn to scale, because if it was, that middle bit would definitely look bigger than the 2 root 3. The 3 root 3 would look bigger than the 2 root 3, which it obviously doesn't. Okay, but nevertheless, or nonetheless, we're going to put that on the diagram. And what I then know, because I've got this rectangle, because of the symmetry, I am going to have right angles between the two blue lines, as you can see here. Okay. Now, what I can then do is I can introduce this diagonal of the rectangle, and I can use the circle theorem that the angle in a semicircle is 90 degrees. And so because we've got this triangle here with a 90-degree angle in it, this red line must therefore be the diameter of the circle. And so what we now just need to do is work out the length of that red line. Now we know that the length at the bottom here, this black chord at the bottom, is going to have the same length as this middle black chord, so 3√3. And we also know that the length of the blue line is going to be 13 because it's the same length as the other blue line, 10 plus 2 plus 1. So that means to work out the length of that red line, or the diameter of the circle, we're going to do 3√3 squared plus 13 squared and square root it. So using Pythagoras gives us an answer for the diameter of 14, which then to get the radius, you're just going to half that, so we get a radius of 7. Now, if you had a go at this problem yourself and you used the same solution or a different solution, whichever solution you used, share it down in the comments below so that other people can see how you were able to do it, how you managed to do it. Either of those things. I'm tripping up over my own words. Now, all that's left to say is thank you so much for watching, and if you haven't already and you enjoyed the video, drop a like on the video, and if you're not already, consider subscribing to the channel. We've just recently reached 1,100 subscribers, which again is crazy. You know, every new milestone that we reach is yeah, crazy to me. So thank you to everybody that has subscribed, and if you're not already, like I say, drop a subscribe to the channel. Thank you so much for watching. Have a great week, everybody. I'll see you next Monday, 5 PM, for another problem solving video. Until then, bye bye.